Hello students! Last week, we finished discussing mirrors. Now, we will go to lenses. What are lenses? Lenses are a piece of clear plastic or glass with curved surfaces. So, light refracts most of the outer surface while no refraction occurs in the middle. Light rays will either converge or diverge behind the lens. So, ano ba itong tinatawag natin na refraction? Kung nung last week, pinag-aralan natin yung tinatawag nating reflection or bouncing of light rays, when we talk about refraction, it is the bending of light rays. Nangyayari lang to kapag magkaiba yung medium kung saan dumadaan yung light. So halimbawa, nanggaling siya sa air, tapos pupunta sa water, or vice versa. Kapag nagbago yung ating medium, nagkakaroon ng bending or refraction. We have two types of lenses. We have a converging lens or a convex lens and a diverging lens or a concave lens. Ngayon, kung naaalala ninyo yung pinag-aralan natin last week, siguro malilito kayo kasi last time, ang tawag natin sa converging mirror ay concave mirror at yung diverging mirror naman ay convex mirror. Magbabaliktad siya for the case of lenses. For this time, we will call converging lenses convex lenses and diverging lenses concave lenses. So mamaya malalaman natin kung bakit ganon. Okay? So dito sa baba makikita natin yung itsura ng isang converging lens at ng isang diverging lens. So makikita natin yung converging lens, thicker siya at the center. Okay? And it is called converging because it converges the light rays towards the focus. On the other hand, we also have the diverging lens or the concave lens. As you can see, kabaligtaran naman po yung nandito kasi the light rays would diverge as they come through the lens. Also, as you will notice, the lens is thicker at the edges. Kanina yung convex lens, mas thick siya sa center. We have different subtypes of converging and diverging lenses. We have biconvex lenses, we have plano-convex, we also have plano-concave, biconcave, negative and positive meniscus. But for the case of demonstrating the ray diagrams for each, we will be focusing on biconvex and biconcave. Para mas madaling tandaan, pag convex ulit, mas mataba sa gitna or thicker at the center, whereas for a concave lens, it is thicker at the edges. Let's go now to the ray diagrams. Last week, you were able to see the different ray diagrams produced in mirrors. You will be seeing a similar set of ray diagram this week, but then there are a few changes that we have to take note. Okay, ano po yun? Ayan, so we have here a simple ray diagram for a converging lens and later for a diverging or a concave lens. As you will notice, the difference of this ray diagram from the previous ray diagram for mirrors is that instead of having F and C, you now have F and 2F. Alright? And also, you will notice that there are a lot of times when the image formed will be on the other side of the lens. So, tatandaan po natin pag ang ating object ay nasa left at ang image ay na-form sa right, that image is a real image. On the other hand, if the image is formed on the left side or on the same side as your object, then that image will be a virtual image. I'm stressing this kasi baka malito po kayo dahil baligtad yung nangyari sa mirrors. So again, if you have the object on the left and the image is on the right, the image is real. If you have the object on the left and the image is also on the left, then the image is virtual. Now let's start with some simple ray diagrams. So we have here the converging lens. Okay, and we also have here the diverging lens. Tandaan po natin yung pagkakaiba. Babalik lang natin sa converging and then I will change the object to be an arrow. Tapos lakihan natin ng onte. And I will be showing all the lines. Okay? Again, katulad dun sa ating ray diagrams for mirrors, we have a line that is parallel to the principal axis and passing through the focus. Okay, we also have a line that is passing through the focus, the first focus on the left, and then coming out parallel towards the other side. And we also have a line passing through the center na dire-diretso lang. So ngayon, what I'm trying to demonstrate is the image formed when you have an object that is very far from your lens. So, ang gagawin ko ay medyo liliitan ko yung focal length para makita natin kasi ayaw niyang gumalaw. Okay, so as you can see, when you have an object that is very far or located at infinity with respect to your lens, your light rays would converge on the focus on the right side. Ibig sabihin, the image will be formed at the focus. Now, if we try to move the object such as it will be beyond 2F, ayan, what you can see is that the image formed is smaller, real, okay, kasi nandun siya sa right side, inverted, and located in between F and 2F. Okay? Paano naman pag nilapit natin, nilagay natin si object sa 2F? You will see that the image will also be formed at 2F. It will have the same size as your object, but it will be inverted. Dahil nasa kanan siya at nasa kaliwa si object, the image is real. If you place the object in between F and 2F, your image will be formed beyond 2F. It will be inverted, larger, and real. Next, if we place your object at F, okay, the image will disappear kasi maliit lang yung ating screen. So that means that the image is at infinity. So we cannot really describe our image kasi napakalayo niya. And then finally, if we place our object in between F and the lens, you will notice that the image will be formed on the same side as the object. So that means that the image is already virtual, but then it is larger and upright. Okay, so that's all for converging lenses. Tandaan natin ha, ito yung ating image. Let's go to diverging lenses or concave lenses. Anong mapapansin natin dito? You will notice that wherever you place your object, so as you can see, I'm sliding it towards the right, the image is located at the same place and it will have the same orientation and nature. So it will always be smaller than your object. It will always be virtual kasi same side siya as your object. It will always be upright. Okay, again, the image form for diverging lenses for any case wherever you place your object is that the image is virtual, the image is upright, and the image is smaller. And the image is formed in between F and your lens. So that's all for our ray diagrams. Let's go now to our calculations. So if you remember, I used the same slides when I discussed the mirror equation kasi we will be dealing with almost the same equation. But now we will be naming it lens equation kasi we will be using it for lenses. So the lens equation is given by 1 over f is equal to 1 over do plus 1 over di, where f is your focal length, do is your distance of the object from the lens, and di is the distance of the image from the lens. Okay, so what are some important sign conventions here? If your lens is converging or convex, your focal length is positive. If your lens is concave or diverging, your f is negative. If your image is real, pag sinabi nating real, si object ay nasa kaliwa, si image ay nasa kanan ng lens, ang distance ng image natin ay positive. Okay, kapag ang image naman natin ay virtual, it means that it is of the same side as the object, then our image distance should be negative. So these values will give us idea on the nature of our lens and image. So we also have the magnification. So again, we will be using the same equation. So m, or magnification, is equal to height of the image over the height of the object is equal to the negative of the distance of the image over distance of the object. So ano yung mga variables na yan? They are written below. So basically, they are the same as that with mirrors. However, we change the term mirrors with lenses. Also, the sign conventions, ang important lang naman dito is for the distance of the image. Again, if the image is real, your distance would be positive. If your image is virtual, then the distance would be negative. Now, for magnification naman, if you have a value in between 0 and 1, that would be a smaller image. If you have a value greater than 1, then that would be a larger image. And if you have a value that is equal to 1, the image size and the object size are the same. So the negative sign gives you an idea on whether the image is inverted or not. Pag positive ang M, ibig sabihin upright po ang ating image. Kapag naman negative ang M, ibig sabihin si image ay inverted. Alright, so let's go to some sample problems. So first problem, an object is placed 20 centimeters from a convex lens, forming an image behind the lens with a 30 centimeter distance. So what is the focal length of the lens? Ito napakadali lang na problem kasi we are given the distance of the object and the distance of the image. And when we say that we are given a convex lens, okay, we are expecting that the focal length should be positive. So, ayan. We have here, okay, so I will be drawing a tentative ray diagram for the image formed. Ayan. So, tentative lang yan kasi we still don't know what is the exact size. So, please, wag po nating isipin, so please take note that my drawing is not to scale. And ayan, I'm labeling which is the object and which is the image. So again, we are given, okay, the distance of the object equal to 20 centimeters. And then the distance of the image, okay, sabi behind the lens, so sa likod ng lens yan, that would be 30 centimeters. Tandaan po natin, kapag real ang image, positive po ang ating DI. And we are looking for F. For our equation, we will be using the lens equation, which is 1 over F is equal to 1 over DO plus 1 over DI. So we will simply substitute all the values into our equation to solve for F. So 1 over F is equal to 1 over 20 plus 1 over 30. So that would give us 1 over f is equal to 1 over 12. Okay, so that would be f is equal to 12 centimeters. Okay, the value is positive, which confirms that our lens is a convex lens. Okay, however, we have to redraw our ray diagram a bit kasi we have a focal length, okay, para mas malapit siya sa katotohanan. So our f would be here, okay, and 2f here. So f is 12 centimeters, so 2f is 24 centimeters. So that would mean that your image would be formed beyond 2f, and that confirms, kasi a while ago I showed you a ray diagram, and that whenever the object is located in between f and 2f, you will have an image that is beyond 2f, inverted, larger, and of course, real. So next problem, a small insect is placed in front of a diverging lens with a 30 centimeters focal length. If its image is 5 centimeters on the same side as the object, where is the insect located? So we're given here a diverging lens, so therefore the value of f should be negative. Let's try to draw the ray diagram. F is 30 cm. So the image is formed 5 centimeters on the same side as the object. So, di ba, if you remember the ray diagram a while ago, for a diverging lens, wherever you place the object, it will form the same image, the same orientation, the same nature. So, it's quite difficult to guess where the object is located or where the insect is actually placed. So, we have to solve. Okay, so I will be placing it here first. Again, this is just an estimate. Later, we will be confirming it. So we are given the value of f, which is negative 30 cm. And we also are given the value of the di, which is 5 cm. And then we are asked to look for do. For this problem, we will still be using the lens equation. 1 over f is equal to 1 over do plus 1 over di. So solving for 1 over do, we have 1 over do is equal to 1 over f minus 1 over di. Then we have to substitute the values into our equation. Okay, so that would be 1 over do is equal to 1 over negative 30 minus 1 over 5. Okay, so I think we forgot to add the negative sign okay, into our DI because again, sabi natin dito, the image is formed on the same side as the object, so therefore the image is virtual and DI would be negative. So, yan. Don't forget that. Let's not forget that kasi otherwise we will be getting a different answer. DI is negative 5 cm, so we add a negative 5 here. Then 1 over DO is equal to 1 over 6, therefore giving us the value DO, or the distance of the object from the lens, is 6 centimeters. Okay, so therefore our first estimate is not correct kasi we placed our insect in between F and 2F, but in reality it should be in between F and the lens. Okay, let's just erase that and then draw it here. Okay. A 2 centimeter high object is placed 5 centimeters from a 20 centimeter focal length converging lens. First question, where is the image located? Second, compute the magnification of the image. And last, find the image height and describe its nature. So, drawing natin yung ating ray diagram. So, sabi dito, 20 centimeters ang focal length. And the object is 2 centimeters high, placed at 5 centimeters. So, F would be 20 and then the object would be here kasi 5 centimeters lang. Again, the drawing is not to scale. So, medyo dyan ko lang nilagay para makita siya. Pero in reality, dapat mas malapit pa siya doon sa ating lens. So, we will be estimating that our image would be here in between F and 2F. So, prediction pa lang po yan. We will be checking later kung nasaan na form si ating image. Anyway, we are certain that our image would be virtual. So let's write the given values. The first given value is the height of the object, which is 2 centimeters. And then the distance of the object from the lens is 5 centimeters. The focal length is 20 centimeters. So first we're looking for DI, and then for M, or the magnification, and then the height of the image, and also the nature of the image. So let's first find DI. So how do we solve DI? Of course, we will be using the lens equation and the magnification equation kasi we are also looking for the magnification here. I will be writing these equations here. Don't forget the negative sign before DI. Important yan, negative DI over DO. So now for the solution. To find DI, we will be using the lens equation. So we will be solving it in terms of DI. So 1 over DI is equal to 1 over F minus 1 over DO. Positive ang ating focal length kasi converging lens naman siya. So that would be 1 over 20 minus 1 over 5, and we should be getting negative 3 over 20. So, again, the reciprocal of that to get di. So, finally, di is equal to negative 6.67 centimeters. Again, what does a negative sign in di mean? It means that your image is virtual or the image is of the same side as your object. So, ibig sabihin, our prediction that your image is virtual would be correct. Ngayon, titingnan na lang natin kung saang position ba nakalagay talaga ang ating image. Okay, so although tama yung ating prediction na virtual yung image, mali yung ating position kung saan natin siya nilagay. Kasi sabi, 6.67 centimeters siya virtual. So, dapat malapit lang siya sa position ng ating object. And in between F and our lens. So, let's go now to letter B. We are asked to compute for the magnification of the image. So, kung lumaki ba siya and by how much. So, M is equal to negative di over do since we already have these values. So, negative times negative of 6.67 centimeters all over 5 centimeters. Then, we will be getting a positive value kasi negative times negative. And that would be 1.33 for our magnification. So, what does a value of 1.33 mean? Positive, ibig sabihin yan, siya ay upright. Okay? And greater than 1, ibig sabihin, mas malaki siya. For the image height, okay, we have M is equal to HI over HO. Then we solve for HI. Okay, we have here 1.33 times height of the object of 2 centimeters. So, we will be getting 2.67 centimeters. Okay, diba? Mas malaki siya sa ating object. Our object is 2 centimeters. Ang kanyang height, yung image natin ay 2.67 centimeters. So, again, it is larger. It is upright, given by the positive sign. And the image is also virtual kasi makikita nga natin, the image is formed at the same side as the object. Okay, so that's all for today. I hope that you have learned something about lenses with regards to their ray diagrams and the equations that we can use to accurately describe the images formed in each type of lens. If you like this video, please click the thumbs up button and I will really appreciate it if you can share it with your friends. See you in my next lesson. Bye!